I'm Anil Kumar. Welcome to my series on definite integrals. As very important applications of integrals, we'll find out formulas for volume of solids. In this video, we'll discuss how to find a formula for volume of a sphere. Well, you know that the volume of the sphere V is given as 4 by 3 pi r cube, where r is the radius of a sphere. Now, using integrals, we'll actually figure out how to derive this formula. So here we have a sphere. Now, let us consider the origin to be the center of the sphere. So I'll draw my y-axis vertical going through the diameter and x also through a diameter, but horizontal this time, right? So we have these two axes. So that becomes a sphere with center at origin, right? Okay. And any point on the sphere is at a distance of r, right? Now it looks like a circle, but it is, imagine, a three-dimensional sphere. Now let us say we slice the sphere with a plane through this point. If we cut a slice out of the sphere, how will it look like? Well, it will definitely look like a circular disc, right? So it will look like a circular disc, which could be shown as like this. Correct? Now it gives you more of a look of a sphere, right? So what we have done here is that we have cut a slice. So that is a slice out of this sphere. So that becomes the height of this slice, which we can say is, let us say, y. And let us say that we have cut this slice x distance away, right? So this distance from here, center, to the point where we have cut the slice is x distance away. Now in this particular case, we can find a relation between radius y and x, correct? So from here we can say radius r is basically equal to y square plus x square, right? We can say r square is equal to y square x square. Okay, so that relates r, x and y at any instance of time, where we know that r, which is the radius, is a constant. Correct? Now, as far as this slice is concerned, let's look into this slice in more details. So let's say we have this slice, which is a disc, right, of a thickness. Let's give some thickness to this disc. So what is the area of this? Now, as shown here in the figure, y could be the radius of this circular disc, right? So this is what we have here is a circular disc. Right. Here, the radius is y, right? So area of this disc is how much? Area, since it is a circle, will be pi y square, since y is the radius of this. Correct? Now, if I give some thickness to this, let's say delta x is my thickness of this particular disc, in that case, let's call this as thickness of delta x, right? In that case, the volume will be how much? Volume will be equal to pi y square times delta x. Correct? That small thickness. Then we get the volume of this disc. Now think about our sphere cut into infinite disc of this form, right? So if we cut slices of disk with thickness of delta x each, correct? Then what happens? Then sum of volume of these disks will be the volume of the sphere. Is that clear? Right. So if we cut into such disks, many of them, right, and then add their volumes, then we get the total volume of the sphere, correct? So we can say that the volume of sphere is, we can write the sum as sigma notation, right? This is like sum of volume of each disk, right? So each disk is pi y square delta x, correct? Pi y square delta s, where the value of y actually changes with the value of x as we move along it, right? So we can find what this y is. So from this relation, we can say that y square is basically equal to r square minus x square, correct? So y becomes a function of x, r is constant, right? R is constant. So we can say that this is equal to the sum when x is changing from this place here will be minus r and this place will be r. So what is varying here? Basically, as you move along, it is the x value which changes from minus r to plus r. From minus r to plus r. You understand now? Y is a function of x, right? Clear? Y is a function of x. So we can write this volume of a sphere as equal to pi, instead of y square, let me write this as r square minus x square times delta x, right? These small slices with thickness of delta x, which is constant, right? And x is varying from minus r to plus r. Is that clear to you? Right? Now, if we have infinitely large number of disks, right, for infinitely large number of disks, what happens? Delta x will be approaching 0, right? And what we get here is the integral sum of these disks, right? So we could now write this as integral from minus r to plus r of all this, which is pi r square minus x square delta x. Perfect. So that is how we can actually calculate the volume of this sphere. Now on the next page, we'll work out this integral and find the formula. I hope that sounds good. So let me just redraw this diagram, right? So we took the sphere, center at the origin. We are considering a particular disk here, sliced away from at a distance of x units from the center, right? So that's the disk which we have sliced away, and we know it is at a distance of r units, correct? And let's consider the height here as y, which is x distance away from the origin, correct? And we also figured out that the volume could be written as the integral from minus r to plus r, right? So those are the two extremes which x value can take, from minus r to plus r. Area of each disk is pi r square, right? So pi radius is y, and we found that y is basically what? Y is equal to, you can say y square is basically equal to r square minus x square, correct? So we replaced this y here with r square minus x square, and delta x is a small increment, right? Multiplying with delta x gives volume of each disk, right? You can think about a cylinder with circular area of pi r square and a width of delta x, right? So this integral gives us the volume of sphere. Perfect. Now let's continue. Now this integrand here is symmetric, right? It has even symmetry, correct? So the integrand has even symmetry, correct? And therefore we can say that this is equal to from 0 to r 2 times, right? 2 times pi r square minus x square dx. Perfect. Now the integral will be, pi is a constant, so we get 2 pi, and the integral of this portion is what? R square x minus x cube over 3, and the lower bound is 0 for us, the upper bound is r. Right? Now let's substitute the values. We get 2 pi. Here we get r square times r minus r cube over 3. Right? So if you calculate this, you get 2 pi 3r cube minus r cube over 3. 3 minus 1 is 2. So we get this as 2 pi by 3, and in the bracket we have 2 r cube, which is multiplying, we get 4 pi r cube over 3. Over 3. So we have our formula, 4 by 3 pi r cube. So we have derived the formula that the volume of the sphere equals to 4 by 3 pi r cube, right? Since r is a constant, the integral will be r square times x, right, for r square. And for x square, it is varying, right? So it will be r x cube over 3. Substituting the value of r, minus 0 is 0. So we get our formula. Is that clear to you? So by addition of these disks, we found the formula for the volume of a sphere. So I hope you understand and appreciate all these steps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.